All right, let's dive into one of the biggest, most talked about technologies on the entire planet, artificial intelligence. Today, we're going to peel back the layers and look at the real history of AI. And I promise you, it's a way more surprising story than you might think.
Right now, it feels like AI just exploded out of nowhere, right? Like it's this brand new thing that's changing our world overnight. But what if I told you that the dream of AI is actually decades and decades old? That the ideas we're seeing today were actually born long before most of us were?
See, the history of AI isn't some straight, clean line of progress. It's actually this really dramatic story. It's full of wild optimism, these crushing failures, and then, bam, a sudden explosive comeback that changed absolutely everything. So let's trace that journey. Our story kicks off not in some fancy modern tech lab, but way back in the 1950s. This is where the seed of an idea for a truly thinking machine was first planted.
What's so incredible is that we can actually point to an exact moment, a birth date for this whole field. In 1956, a group of brilliant scientists got together for something called the Dartmouth Conference. And it was right there that the term artificial intelligence was officially born, kicking off this huge wave of incredible optimism.
And they weren't just a little optimistic. They were absolutely convinced they were on the verge of cracking the code of the human mind. I mean, they genuinely thought that creating a machine that could think just like a person was a problem they'd solve within a generation, maybe even in just a handful of years. But they were missing some really crucial pieces of the puzzle.
And this, right here, this gets to the heart of the problem. It was the massive gap between their dream and their reality. The computers they had back in the 50s, they were basically room-sized calculators with a laughably tiny amount of memory. They had no large data sets to learn from, no internet, no digital photos, nothing. To put it simply, their ideas were decades ahead of their hardware. So that huge gap between the promise and what they could actually deliver, well, it led to a long, cold period of disillusionment. The dream didn't just get put on hold. For a lot of people, it felt like it died completely.
These periods became known as the AI winters. You see, all that early hype created these expectations that were just impossible to meet. And when those amazing breakthroughs didn't show up, the funding and the public interest just froze solid.
So why did it fail so hard? Well, early AI wasn't really learning anything. It was just following a giant, massive list of if-then rules that humans had to write by hand. It couldn't handle anything unexpected, it couldn't adapt, and it had zero data to learn from to understand how messy and complicated the real world actually is. The fallout from this was pretty severe. Government grants completely dried up, university programs were shut down, and the entire field of AI got this reputation for being a total dead end. For decades, the thinking was shifting. Maybe creating a true AI was just impossible.
But then, after that long, cold winter, something started to change. The ice began to crack, and the dream of AI was about to be reborn, more powerful than anyone could have possibly imagined. Right around this year, 2015, everything shifted. It wasn't one single event, but more like a perfect storm of factors that had been quietly building up for years. All of a sudden, AI systems started doing things that were considered science fiction just a few years earlier, like beating the world's best Go players and recognizing images even better than people could. So what happened? What was the secret sauce that finally, after all those decades, made AI actually work? Well, it turns out it wasn't just one thing, but a perfect recipe of 3 key ingredients that all came together at exactly the right time.
And here they are, the 3 magic ingredients. First, an absolutely unimaginable amount of data. Second, incredibly powerful new computer chips. And third, these major breakthroughs in the learning algorithms themselves.
Okay, so ingredient number 1, big data. The internet basically became this massive global library for AI to study. For the very first time in history, we had billions of text documents, countless images, and endless videos, all the raw material an AI needs to actually learn about our world.
Number 2, the hardware finally caught up with the dream. Graphics processing units, or GPUs, which, funny enough, were originally designed for video games, turned out to be the perfect engines for AI. They could handle the millions and millions of calculations all at once that are needed to train these gigantic new models.
And finally, the software got a massive upgrade. Scientists developed much smarter algorithms in a field we now call deep learning. Think of it like this. If big data is the library and GPUs are the engine, deep learning is the technique that finally taught the AI how to read all those books and connect the dots.
It could finally find and understand the hidden patterns in all that data. So really, when you boil it all down, that decades-long winter finally ended because we, for the first time, had both the fuel, that massive amount of data, and the engine, that incredible computing power that the original researchers had been missing since the 1950s.
This quote just nails it, doesn't it? You can have all the information in the world, but it's totally useless without the horsepower to actually process it. It's like having a brain with no energy to think. Modern AI needs both to even function. So let's just sum up the entire journey. Early AI was all about handwritten rules, running on tiny bits of data and weak computers to do really simple tasks. Modern AI is the total opposite. It learns from massive, internet-sized datasets, runs on super-fast GPUs, and has the ability to achieve really complex understanding. The difference isn't just a small upgrade, it's a complete transformation. Which leaves us with a pretty fascinating final question to think about. The pioneers of AI were blocked by data and computing power. We've pretty much solved those problems. So what's the next AI winter? What is the next great barrier that stands between the AI we have today and the truly thinking machines of tomorrow?